Hi students, this is Neeraj Bansal and welcome back to my YouTube channel. Today we are going to work on a new topic which is complex numbers, right? So when we are talking about complex numbers, there are basically two types of numbers. Real numbers and complex numbers, right? So till now we have studied only real numbers. What do we mean by real numbers? Any number which is rational, irrational, or any type of number which we have done till now is a real number. But now today we are going to study complex numbers. What is complex number? What is the use of complex number? I'll just tell you. Let's say when we say x squared plus 2 is equal to 0. So you write x squared is equal to negative 2. Then you say no solution. But that is not the correct term. Actually, the correct term is no real solution. Got it? It has a complex answer. Complex answers means what I can do is I square is considered to be negative 1, right? This I is actually not I, it is iota, which is a Greek alphabet, right? This is equal to negative 1. So if I want to solve this, it becomes x squared is equal to 1i squared. It implies x is equal to plus minus under root plus minus I. Got it? So this is what complex number is all about and what is the use of complex number. So this complex number has two parts, a real part and the imaginary part, right? So complex number has two parts, real and imaginary. So when we are talking about a complex number, the general form of a complex number is a plus minus bi. That means either a plus bi or a minus bi. This thing is called the real part and this thing is called imaginary part. Normally we represent a complex number by a letter either z or w, although you can use anything, but normally we use this. So z, let's say z is my complex number a plus bi. Then if I change this sign to negative, it is called complex conjugate. So a minus b, it is represented as z star, and this is the complex conjugate of a number z, which is a plus bi. Hope this is clear, right? So then we talk about the operations on complex numbers. What do we mean by operations on complex number? Addition. Number 2, subtraction. Number 3, multiplication. And number 4, division. Let's say we have two complex numbers, z is equal to 4 plus 3i and w is equal to 2 negative I. So what I want to do is addition. That means z plus w. So it will simply be 4 plus 3i plus 2 negative I. So complex will do with complex and real will do with real. So 4 plus 2 is 6. 3i minus I is equal to, this is my answer. Yeah. Then we talk about z minus w. So this is 4 plus 3i minus of 2 minus I, which is 4 plus 3i minus 2 plus I. This is 2 plus 4i. So this is my answer. So this is addition, this is subtraction. Let's talk about multiplication and division. So if I'll talk about, let's say, z times w. Got it? So this will give me 4 plus 3i times 2 minus 3i, which will give me 4 2s are 8, negative 4 3s are 12i, plus 6i minus 9i squared. 8 minus 12i plus 6i is minus 6i, and then I square can be written as minus 1, right? So this becomes plus 9. So 9 and 8, 17 minus 6i is the answer. Clear? Now let's talk about the division. That means z over w, which is 4 plus 3i over 2 minus I. 4 plus 3i over 2 minus I. So I want to rationalize the denominator. How I will do it? I will multiply it with its complex conjugate. So plus I is the complex conjugate of it. So 2 plus I over 2 plus I, which will give me 4 times 2, 8 plus 4i plus 6i plus 3i squared. Then I come to 2 squared minus of I squared, right? Then it becomes 8 minus 3 is 5 plus 10i over 4. And then I square can be written as minus 1, so minus minus. So this is 5 plus 10i over 5. Then it comes to be 5 times 1 plus 2i over 5. So 5 cancels 5, which is equal to 1 plus 2. Got it? Now we'll talk about the properties of a complex conjugate. Properties of complex conjugate, right? So now we talk about z times z star is equal to z squared, right? Z w whole star is equal to z star times w. Got it? Z over w star equal to z star over w star. Yes? So these are the properties of complex conjugate. One more, z n whole star is equal to z star whole n, or vice versa. I hope this is clear. It will be further clear when we'll do some questions, right? So let's try doing some questions on all of these concepts, whatever we have. Let's do these questions. How do we? Let's take this and this, right here. So first let's do this. So negative a part I'm doing for this. A part is saying under root of negative 81. So best way is you can write 81's I squared, which I can write as under root of 81 is 9i. You will only take the positive part, because when something is an under root, it only takes the positive part. Got it? So B part says minus of under root negative 3. This is negative under root of 3i squared. So this is equal to negative of under root 3i. Is this clear? Perfect. Now we talk about these two questions. So let's say x square is equal to -4, and I can write x square is equal to 4i square. Here I can take both plus minus because I'm going to root. So x is equal to plus minus 2. Then I'll do the another one. B is equal to x squared plus x plus 2 is equal to 0. So what I'll do is I use the quadratic formula, right? So how will I use the quadratic formula? A is equal to 1, B is equal to 1, C is equal to 2. So my quadratic formula is minus B plus minus under root of B square -4AC over 2 times A, which will give me -1 plus minus root of 1 minus 4 times 1 times here over 2, which will give me -1 plus minus under root of 1 minus 8 over 2. This will give me -1 plus minus root of -7 over 2. See, in previous classes, you will say there is no solution for this because b square minus 4ac is less than 0. But here we will not say what the correct statement is. It does not have any real solution. But yes, it does have a complex solution. It is -1 plus minus under root of 7i squared over 2. So this will give me -1 plus minus root 7 I. Here, these are my solutions. I hope this is clear to you. Perfect. Very good. Now let's move to the next questions, or rather the next set of questions. Let's take this. Right. Take this. Right again. Okay, fine. No problem. So let's first finish it off. So let's say z is equal to 3 plus 2i and w is equal to 4 minus I. So I need to do z plus w. Z plus w. 3 plus 2i plus 4 minus I, which will give me 7 plus I. This is my answer, right? And now we want to do z minus w. So z is equal to 3 plus 2i minus of 4 minus I, which will give me 3 plus 2y minus 4 plus I, which is equal to -1 plus 3i. This is clear. Perfect. So these are the two answers. I hope this is clear to you, right? Let's move to some more questions. Let's solve it here only. X squared plus 9 is equal to 0. It can be written as x squared is equal to -9. It implies x squared is equal to 9i squared. It implies x is equal to plus minus 3i. Perfect. We are done with it. Then we can do 2x squared plus 3 is equal to 0. It implies 2x squared is equal to negative 3. It implies x squared is equal to negative 3 by 2. It implies x squared equal to 3 by x squared is equal to 3 by 2 I squared, which will x is equal to plus minus 3 by 2 under root 3 by 2. Clear? Right. Let's move to the next. Right. So basically, understand this. You can keep this thing here and these things here, or you can take everything on the left hand side and make it 0. This means, I'll explain what do I mean. First, we need to solve it. So let's say x plus yi is equal to 2 minus I. So 2x minus xi plus 2yi minus yi squared is equal to negative I. What I can write is, I'll separate the real and the complex part. So I square is equal to negative 1, so it becomes plus y. So 2x plus y is one side, right? And I times 2y minus x is another side. So this is equal to 0 minus I. So I can say I have two equations, 2x plus y is equal to 0, equation 1. And 2y minus x is equal to minus 1. This is my equation 2. Comparing the coefficients, right? I have compared the real parts and I have compared the imaginary part, right? So now let's see what happens. So in order to solve this, I need to either multiply this with 2 or this with 2. So I'm doing equation 1 multiplied with 2. So 4x plus 2y is equal to 0. This is equation 3. So adding equation, not adding. So equation 3 minus 2 is equal to equation 3 minus equation 2. 4x plus x is equal to 5x is equal to 0 plus 1. So 1. X is equal to 1 by 5. So here I have got x is equal to 1 by 5, right? And then if I have x is equal to 1 by 5, I can find the value of this. So 2 times 1 by 5 plus y is equal to 0. By 5 plus y is equal to 0, y is equal to 1. So this is my answer. Right? I hope it is clear up to here. Let's come to the next last question of this. So basically, we want to prove this property, right? I'll just write it now, then we'll come. So z1 plus z2 whole conjugate. So we have to give some name. So z1 is equal to a plus bi, and z2 is equal to c plus di. And obviously z1 conjugate is equal to a minus bi, and z2 conjugate is equal to c minus d. Let's do it. So a plus bi plus c plus di whole conjugate, right? So what I'll write here is a plus c plus I times b plus d whole conjugate, right? So conjugate of this is a plus c minus I times b plus d. So let's write it a plus c minus bi minus di, right? What I can write a minus bi plus c minus di. So a minus bi can be written as z1 conjugate and c minus dy can be written as z2 conjugate. So basically this means the left hand side is equal to the right hand side. I can say z1 plus z2 whole conjugate is equal to z1 conjugate plus z2 conjugate. Hence proved. Perfect. Right? So we are done with basics of complex number. In the next videos, we will keep working on complex number. Right? And if you want any one-to-one session or if you have any doubts, please contact me on the number which is given below, or you can write a comment on it, right? So rest we'll do in the next video, and please subscribe to my